Hello, wonderful community, and welcome to our part 4 of our journey learning how to code for Elrond. And in this part, the focus will be how to deploy contracts at massive scale. So, I'm gonna put up my notes here. This is what we're gonna talk about today. Well, of course, we had the intro. Let's just say, consider that this is done. And then, of course, we're going to explain the problem, the current dev efforts. I had some really interesting chat on the developer channel, Telegram. And a demo, I'll show my solution for this and how does it work. Of course, the Java API code, the Docker file and deploy snippets, and also I'm going to talk about the project environment value. It was very hidden. I had to dig a lot to find out how important that one is. And just for fun, I'm going to show you my initial attempt of this. So, are you guys ready? Let's go! Let's explain the problem. You are a developer and you just developed a really nice smart contract, and it was so successful. So like the people that are using it and having fun, but inevitably you will get a request, can you deploy another contract like this? This is really useful. And then of course you can just go using your development setup and you deploy another contract. But you don't want to do this again and again. You want to automate this because Elrond network is such a good and optimized and fast and scalable network that like you can deploy and invest minimum effort in a very clean and cool smart contract that handles one small thing, and then you should be able to deploy that many times with zero effort. And one such a contract could be something used as inspiration. Let's just pick up like the crowdfunding. You don't need to be like you don't need a crowdfunding to process money, but the idea is like people, they organize themselves, they subscribe to a set of rules and they put money based on a certain rules, and then they get value and do things based on those rules. Something like this could be like a barbecue. So if you build a barbecue where people just barbecue contract of managing funds and doing things and organizing them, you don't want to redeploy again, because like imagine all the barbecues that are being organized in the world, they're gonna rely, they see that this contract is such a useful thing and they're just gonna start using it across the road. And this is you, the developer that wrote that contract. You don't want to use command line to deploy many contracts. You're just gonna die slowly. What you want this process to be very simple, and you want to deploy contracts and maybe people to deploy those contracts on their own and they're just using it. So how do we do this? Before the demo, let's talk a little bit about the current Elrond team dev efforts. As you can probably imagine, I poked around and asked like, how do you do this? Is there a solution already that I can just use? And at the end I will even show you my initial attempt. Kind of like works, but only for like extremely simple contracts. For the crowdfunding template contract, this solution that I will show you at the end, it doesn't work. Before the demo, let's talk a little bit about the current Elrond team dev efforts. As you can probably imagine, I poked around and asked like, how do you do this? Is there a solution already that I can just use? And at the end I will even show you my initial attempt. Kind of like works, but only for like extremely simple contracts. For the crowdfunding template contract, this solution that I will show you at the end, it doesn't work. Elrond development channel on Telegram is like people really helpful, and even Lucian Mincu, when he understood what I'm trying to do, responded to one of my requests. So here we are. Thank you so much, Dinko, for clearing out this. There's also like really cool news in this message. Thank you for the feedback, Bogdan. We're fully aware of the limitations that basically come from the browser link length limitation, not exactly from the Elrond web wallet, and he is completely true that. For contract deployments, we have AirPy, which does this way better. Also, option B is to manually copy paste the bytecode inside the data. field which will pass through the webhook limitation. However, we're looking on other signing methods such as like MetaMask like apps only for private key management and signing, especially for devs. Hopefully in 1 or 2 weeks things would look even better. So wow, thank you so much. I'm really excited that knowing that signing options similar with like MetaMask will come very soon to Elrond chain. Really nice. But even if this type of solutions are available for the Elrond chain, like a truly scalable approach of like deploying smart contracts will cover use cases that this specialized signing solution will not be able to cover. So let's see, what do I mean about that? Demo time. So I have here on my left the API running in a Docker container, and here this one connects directly to this. So just for fun, you would see like the ping only like addresses like hello there. This is the ping. This is the only important part. If you want to play with it, also you have like another, me building upon it and trying to extend functionality. I have this one, run RPi version. So this one, as you see, like there's no message, but it does response here, the path response, and this message RPi 1.0.12 is the message that you get when the application queries the RPi, tell me what version you are. So that was it. And the fun part is this one. This API actually deploys the contract, so it's sufficient to just click upon it, just wait, and there you go. This is the response, like the contract address. We have the address of an already deployed contract, and the only thing that is important here, in case would have been like errors, you would like look at the end, do you have an error? So what do I mean like the contract is deployed? This one is basically you can go to the use the Elrond API to query it. It's a deployed contract live that people can start making use of it. So if I paste here and query the contract, you will see that it was deployed, and there you go. This is the contract. And now if I you know what, I'm actually gonna do this now. If I go to my application, let me just copy the contract address, copy. If I go to the previous application built in part 3, it's this one, crowdfunding web app. Alright, so this is the web app, and let me just paste there the crowd contract addresses. So we're just going to use the address that we had and we just deployed. Okay, we are on start. Let's just give it a little second. So the only part that it's important, okay, documents, so we will ask a while, and then you see the crowd balance, that's like 0 equal. But this application we can send funds, so let's just send 1 Elrond to it, or maybe 1.5 send funds. Just do 1.5 send funds. We sign the transaction. So in my comments that I think you can change is basically this is it. This is locked, as you see. I cannot change the data here. This one, even if I try to type, I cannot put the bytes if I want to deploy a contract. But let's just get back to our funds. This one, we are gonna send 1.5 Elrond. This is to this crowdfunding contract, and there you go, transaction succeeded. We have 1.5 there, and also if we re-query this, execute again, we will also see the balance here, but this is the nominated value but it's the same. Alright, so this, we basically gonna learn how to build this, because we can just deploy another contract and just wait. There you go, we have another address. You want to deploy another contract, why not deploy another contract? So this is what we want, easy deployment of specific contracts. How does it work? Well, yes, you can kind of like have it managed. I have like a Spring application, a Java Spring application that runs in a very special Docker container. And so we have the application and a Docker container. So basically this is it. So let's talk about the Java API code. So the crowdfunding API is the Java project, and everything is what is it? Source main Java. We have this main controller. Oh yeah, sorry, I don't want to look at it. So we have this main controller at the beginning. Actually, I think it's useful if I just launch again. So like I'm showing you the code and also show you how it works on the other side. So let it build everything. Actually, like yeah, right. It was quite fast, so it didn't make it fast. So localhost. Right. So first things first. I'm gonna close this. Everything happens in this class. When you ping, basically like what it does, the ping method. What is it? This is the. Alright, let's start with like this page here. This is it. Only this one. Like this is home. It's hard coded. A very basic page where I put the link, ping, ERP version, and deploy contract. You see them here. So let's talk about the ping. What the ping does. Nothing much. It's just responding you, hello there, this is the ping. But what it does, it puts it in our response, and our response is a very simple POJO which contains the contract access messages, bash response, timestamp, an environment value. I was using this to actually, I don't think I need this anymore, but I was passing environment, trying to configure the Docker container in a certain way, and it was very useful for me for debugging. There's the exit code from the bash. It's basically this one. When at the ping method, I'm not processing it, and also the error method. As you can see, I've also not processed out for the ping method. So that's the ping. Let's talk about now the AirPi version. This is a very more interesting one. How does it work? So if you search online about like how to I don't remember what search I used, like basically access from Java a bash, and what you need to do is basically you create a process, you specify for that process the builder, and here you say it's gonna be move yourself into a certain directory, and this is the command, basically share command, and this is what my command, AirPi version, this is what I get from the AirPi, and later on is just boilerplate. Alright, start the process. I have a stream gobbler, is basically like a consumer for the stream. Basically pass a string, and what it does is just like, okay, for everything that it's consumed, like you do for each, you pass that one to the consumer. So basically whoever creates this consumer can decide what to do with that string. And basically what I'm doing, yep, that's my string builder, and I'm just saying, yeah, that's my consumer, and basically this is the method that you're gonna do, basically keeps appending strings to this string builder. So after it finishes processing whatever the bash command that I process, I can just convert the string builder to string, so I know what bash did. And at the end, I'll say I'm just building some things. So this is the timestamp, and as I get time to put this there, and also for the bash response, I'm getting the string builder, and I'm saying that yes to string. So that's it for the AirPi version. And the interesting part of like contract deploy, as you see, I am doing very similar with like with the AirPi version. But what I do, my command now, as you see, I'm moving this time into the home folder, my contract and interactions, and from there what I need to do is just to launch this script. So this script will deploy a new contract, and later on what I'm doing is I'm just parsing the bash response. I'm depending like I'm just gonna go and show you. So crowdfunding interactions, this is the deploy script. What I do here, I just put it used to be like space, I just put this semicolon here, so I know I have the address on the right and the message on the left, so I can do very simple checks which are pretty good. So do you have to, only in case like, okay, you need to have two parts when I'm splitting the string, and I'm checking, you need to make sure that if this is not equal to the message received, then I have an error and just return, and then we take in the second section of the message and we assign that to the address and we put that in the response, and this is how we have this address. So that's it for the Java code. Let's move now to the very interesting and hard part, which was for me the Docker build file. Oh man, it took me about like a week to figure out this, but we have it. So just as reference for you guys, in the Docker file I'm using the adopt OpenJDK because I'm running a Spring application, so I need a Docker image that runs on JDK. I tried with the Alpine images, but I was just creating myself problems because there were things missing when trying to install AirPy, and I had success when I moved to Ubuntu. So based on Ubuntu, what I do, this section here is basically copied from this Git repository. This is being generated almost like the daily basis, so if you want the latest version, you come here and you take it from here. So like the part that I did and I built upon this one is the following. So let's read through it. Basically I am creating here the group and the user Ubuntu. This is just a message, debug message, and then we need to install Python 3. Even if at the top I did added Python 3 and Python 3 pip, well, actually it's not 100% like that. I modified the update and install section with the bits that I needed to do. So what else is new here is Python 3 and also Mono, GNOME compiler for C, GCC, multi-lab. It has special libraries that was like curl. Also we needed wget, libcurses. These are all like pieces that you need, but it's not enough. So we come in here. You need. This is where we configure Python, and this is where we configure Rust, and this one is where we launch the AirPy up. And now this is not needed, but I'm what is happening in this current Docker image, and I'm not able to run the tests. I mean, I can run them in my own machine, but I cannot run the tests for the contract in the Docker environment, and there is some links missing, and I was trying to build it on myself. I still need to figure out how to do that, to also test to be able to run in a container, but for now I cannot do that. I can deploy the contract though. Alright, so we're done. We're setting some resetting the environment, and now what we do, this is from the source code. So basically from some very important things is the following. We are copying the entire crowdfunding. Is basically I'm copying this entire folder. Let me close everything so you guys see. This is the web app, the one that has the nice JavaScript React web application. This is the API, which is the actual Spring API, and this is the crowdfunding smart contract. So I'm copying the entire contract. I'm saying, yeah, copy it there, you home Ubuntu contract, and then later on we assign. I need to do this for some reason. This copying gets some files locked, and when I'm trying to compile the contract there, I cannot. So I need to wait until I reassign all the rights from this folder to the Ubuntu user, and then okay, I move there and I build the contract. I'm running RPi contract build. I'm moving back to Ubuntu. So what I do here right now, I'm copying I'm setting, this is the web application jar. This is the secret. It's like, you guys really need to do this carefully. Don't ever commit to any repository PM file. This gives complete rights. You don't need to sign, you don't need like a password, nothing. Complete control to your funds. So you need to know what you're doing. Don't ever do this. Don't expose this Docker image anywhere public. Use only private Docker repositories from Google or from Amazon, but are private. Only you have access to them. Don't ever publish a Docker image like this on the Docker Hub. And also in the Git repository, if you guys go to my Git repository, you'll see that you will not see this, and because this comes from script security, so the API scripts security, I have this git ignore. You need to create this git ignore before you do any commits or adds. So this one tells like, hey, ignore everything that's in this folder. This is security stuff. As you see, I also have like a Google private key here, and also like the test PEM. I'm not even gonna click here while I'm recording because it's security related, but don't push it to any repository. I cannot stress that important enough. That's how important it is. This file gives complete control to your wallet, so be careful with it. And later on, copy the application there, and also put the PEM file so you can use it from the command line. And okay, we need I think I needed this for testing. I was reading messages, but I don't, it's not in anymore, but it's still there. And the project, I'm gonna talk about the project environment now. The project environment, I was basically, until I did not set this, and it's not documented anywhere, until I did not set this project environment variable in my environment, I was not able to build. I was like working on my workstation, I was just not figuring out why. And after about like 2 days of digging out and figuring out like how does this extension work, this one from here, I got it. I kind of like understood. It was just like when I was like really tired, and I was just looking in the wrong location. Actually, I was looking at the right location at the right time, and I noticed, yeah, hold on, I never set any of this variable. And this is the hint for that. If you go to the snippets from the contract, and this is where I got it. So deploy snippets is this one. No, proxy is not even here. I don't know how I got it, because you don't even see it here. It's not listed. I think I listed all my environments. I was trying to compare them, and I did the git diff between running from myself on a completely separated, not one of this Eclipse Elrond workspaces, because I needed to know everything in order to be able to replicate and deploy smart contracts. So that's it so far with smart contracts. Let me show you guys. I don't know if it works. I'm gonna look at let's talk about my initial attempt. My initial attempt was the following. Is one related to also like response from Lucian Mincu. And is where's the code? So is this one 02 web app, so yarn start Okay, so while the application is running, let's just look at how this application is working. The application, the way it's working for this one initial attempt is, what is important for it is this file, is the deploy util. Basically this one, what it does is just picking the binary files from the, I was working with the crowdfund, so it was not working, but it does work with the other account, so this one will work this time. So because it loads the binary from the WASM, I put them in the public folder here, so it gets it from here, and then it just calls this signer provider send transaction, and this one calls the webhook. So if we log in and to see this one working, was like documents, we can deploy a smart contract like this. There you go. No, sorry, we logged in. Deploy contract, and then deploy contract, and you see it's getting it and it's putting it in access wallet, and this is where the bytecodes are being placed. But it only works with small contracts, so we can just confirm, we wait for the transaction, and in response here we get in the address bar, you see, we get the address from the deployed contract. We can look at it and to see that actually that contract got deployed, but moving back to the a more reasonable contract, so let's go get back to and modify it. Say, okay, no, I want to use the crowdfunding contract, and just wait. And now if we deploy, there you go, it already said no, can do. Thank you everyone for staying with me until this time. If you consider this content useful, then please share, like and subscribe. For extra information, check the notes below, and I see you all next time. Bye.